Right. So let us start from where we have left in the last class. Okay. Now, in the last class, we were, as you can see on the board, I hope all of you could recall that I was talking of the various formations that we have on the ocean floor. So we understood that just help, give me a moment. So we had started a discussion around the ocean floors, and we had seen that before the Second World War, the understanding of the ocean floor was that the ocean floor was a flat, featureless surface, okay, with nothing, no formations, etc. on the surface. But during the Second World War, when the deep ocean floor studies were made, okay, so we came to know that on the ocean floor also there are lot of features that we have, okay. So lot many features were identified on the okay. So a lot of features were there on the ocean floor, and these ocean floor features told about the various formations that we had on the ocean floor. So basically we understood that uh, we had these continental margin region, and in this continental margin region we had the continental shelf, continental slope, and continental rise. Okay, then we also saw that we have two types of trenches that we find. One is the trench near the continental uh, margin, and another trench that we had away from the continental margin, okay, in the open deep ocean, right? So these were the two types of trenches we saw. Then we saw about the gyots, the ridges, which are the hills or peaks in the ocean, which are below ocean water, and gyots, which are flat topped mountains, okay. So gyots, hills, etc. We had done all this, I guess, okay. And then we saw that we also have islands, and finally the mid-oceanic ridges, right? So mid-oceanic ridge was the last part with the central fault, and then we saw that so many features were already existing there. And then the next question was that how were these feature formed? I think this is where exactly where we left, right? So we didn't answer the question how they were formed, okay, but we saw that there were these features, okay, right? So hopefully this much is clear broadly to all of us, no major doubts, okay. Now, was this all that we came to know about the ocean floor, or were there other things also about the ocean floor that we realized? Okay, so you can, I would now like want you to write down in your copy that in addition to the features discussed above, in addition to the features discussed above, to the features discussed above, there were also other there were also other characteristics of the ocean floor, characteristics of the ocean floor that we realized, that we came to know about. That we came to know about. Based on the studies done after the Second World War. Based on the studies done after the Second World War. As given below. As given below. Right. So these were the additional characteristics that we came to know, which also helped us in understanding the ocean floor. What were the additional characteristics? You can write. One, we found that continuous slow volcanic eruptions, continuous but slow, continuous slow volcanic eruptions take place, continuous slow volcanic eruptions take place all along the central fault, all along the central fault of the MOR's mid-oceanic ridge. Mid-oceanic ridge we will also be calling as MOR, central fault of the MOR, causing large amount of lava to come out, large amount of lava to come out over the MORs, over the MORs, MOR mid-oceanic ridge, which solidify and turn into rocks, solidify and turn into rocks gradually. Solidify and turn into rocks gradually. Spreading on both sides of the central fault, both sides. So this side as well as that side, both sides of the, spreading on both sides of the central fault. Full stop. Next, second point. Rocks found on both the sides, of the central fault, this side as well as the other side, both the sides of the central fault of the MOR showed great similarities in terms of great similarity in terms of age, chemical characteristics, and magnetic properties. Magnetic properties when samples were collected, at equal distance, samples were collected at equal distance on both the sides. Okay, equal distance on both the sides. What does this mean? Please try to see here and understand. This is very important character. Okay, so please see it here. What this means is that suppose this is the mid-oceanic ridge and this is the seafloor, let us say. Okay, and this is the central fault. Central fault. If you want, you can draw this for your own understanding. And this is the MOR, mid-oceanic ridge. So if we took rocks of at equal distance on both the sides, for example, if we took rocks from location A and location A dash on both the sides, then A and A dash rocks showed great similarity. The rocks at A and A dash showed great similarity. Similarly, if we took rocks from B equal distance on both the sides, B and B dash, then the rocks B and B dash showed great similarity. Okay. Similarly, if we took rocks at C dash and let us say C, then C and C dash. So A and A dash, B and B dash, and C and C dash showed similarity of age rocks taken from A and A dash, B or B dash, C and C dash showed similarity of age, chemical composition, chemical and magnetic characteristics. You can write. Okay. So these rocks showed, but if you compared A with B, A compared with B and B compared with C, A, B and C did not show much similarity. So A was slightly different from B and B was slightly different from C. Same ways, A dash was different from B dash and B dash was different from C dash. Okay. So if you see on the same side, they did not show similarity, but if you see equal distant on both sides, then they showed similarity. So this was a very special kind of a observation that we had, that this kind of similarity of age, etc., these rocks showed. Okay. Then next point, third point. The age of the rocks was found to be youngest. Age of the rocks was found to be youngest near the central fault. Why this happened is what we have to understand, Vishal. Okay. Okay, that's where the theory will come. So first you will observe something, then you will see something which you don't understand, then you will try to find the answer, and that is the theory. That answer will become the theory. Okay. So third, the age of the rocks was youngest near the MOR. Age of the rocks was youngest near the MOR. And as one went away from the MOR, on either sides, this side or that side, whichever side, on either side, comma, the age of the rocks kept getting older. Age of the rocks kept getting older. Age of the rocks kept getting older gradually. So it wasn't suddenly getting older. So as you kept moving, gradually the age of the rocks kept getting older. Okay. And the oldest rocks. So next point you can write. Next point. the oldest rocks were found on the ocean floor were found near the trenches, near the trenches. So youngest at the central fault and the oldest, let us say there is some trench, okay, somewhere like this. Some trench was there, right? So the oldest rocks were found at the trenches. Where the trenches were there the rocks were found, right? Next point. Mid-oceanic ridge, explain again. Please watch that part of video again, right, where I have explained. Don't ask me to repeat things, especially in the next classes. I generally recommend this because I have already explained it earlier. Mid-oceanic ridge is the part which is the in this diagram, ये वाला diagram, it is a large mountain-like chain, like the Himalayas on the land. They are the mountain-like chains in the ocean floor, and they have a crack somewhere in the middle, right? And from that volcanic eruption comes. And what is the average height of this? You have already written 2.5 kilometers is the average height of these mid-oceanic ridges in the ocean. All right. So, और थोड़ा सा ये parts आप पीछे rewind करके भी देख सकते हैं. Then, sir, what is the age of oldest rocks we have found? Okay, we are coming. Don't worry. Okay. So, mid-oceanic ridges. Then, coming back to this, the oldest rocks at the trenches. Next point. Despite of the oceans having formed, despite of the oceans having formed around 4 billion years before present, 4 billion within bracket 4,000 million, 4 billion within bracket 4,000 million oceans were formed, 4 billion within bracket 4,000 million bracket close years before present, along with the continents. So continents were also formed at that time along with the continents. And though some of the oldest rocks we have been able to find on the continents are around 3,200 million years old. Some of the oldest rocks that we have been able to find on the continents are around 3,200 million years old. 3,200 million years old, comma, yet on the ocean floors, we have never been able to find rocks. We have never been able to find rocks older than 200 million years. 200 million years. So ocean floor were formed around 4,000 million years before present, but we have never been able to find rocks older than 200 million years on the ocean floor. But on the ocean floor, we have never been able to find rocks older than 200 million years old. Stop. These oldest rocks, 200 million years old, are found near the trenches. Right? So where do we find the oldest rocks? Near the trenches. Where do we find the newest rocks? At the central fault of the MOR. Do we get what is the oldest rock we have been able to find in the ocean? Around 200 million years only. Oldest on the continent, 3,200 million years. Okay. So this is another important thing. Then the next characteristic. So if in this diagram, if we have to draw, where will I find the oldest rocks? This one, let us say this is the trench. Okay, another side I'm showing trench. So where will I find newest here and oldest here, right? So newest rocks we will find at the central fault and the oldest rocks we find near the trenches. Do we get it? And in this diagram, obviously at C dash, but the C dash is older amongst the three, but the oldest we'll find at the trench. Okay. Is this okay? Very good. Then next characteristic. Write down the next characteristic. Though we expect to find very old sediments, within bracket thousands of millions of years old, very old sediments within bracket thousands of millions of years old, very old sediments thousands of millions of years old, on the ocean floor 200 million. Yes, how can it be 200 billion? Earth itself was formed 4 billion years, na? Priyanka. So 200 million तो मतलब 200 बिलियन साल पहले तो हमारा बिग बैंग भी नहीं हुआ था ना, ठीक है? So let us not confuse, right? Come back. क्वेश्चन पूछने से पहले थोड़ा सोचना भी है, ठीक है? Don't jump to a question. So next, that though we expect to find very old sediments within bracket thousands of millions of years old, bracket closed, on the ocean floor, which might have accumulated from the continents, right? So we expect that from the continental margin or continent, very old sediments will accumulate on the ocean floor. They will come from the continental margin to the ocean floor and accumulate. How old? Thousands of millions of years old, right? But continue to write. But we only found a relatively much thin layer of sediments than expected, THAN, very thin layer of sediments than expected, and also nowhere we found the sediments also, to be older than 200 million years. So the oldest sediments also that we found, sediments from the continent that came and deposited on the ocean floor, we thought we will get thousands of years old sediment, thousands of millions of years old sediment, but we never found more than 200 million year old sediments also. and we expected to find a thick layer of sediments, right? Accumulated over thousands of years. But again, we found a relatively much thin layer of sediments. Okay. So we found a much thin layer of sediments, and we found the sediments never to be older than 200 million years old. Is this okay? Right. Then next characteristic. We also found that earthquakes were continuously occurring. Earthquakes were continuously occurring both along the MORs, both along the MORs, both, comma, along the MORs, mid-oceanic ridges, but these were relatively shallow focused. I hope you remember that focus word, how deep the focus point is. Shallow focused. We'll understand why all this, don't worry. Shallow focus. Whereas we also found earthquakes along the trenches, and we also found earthquakes along the trenches, but they were deep focused. Deep focus. They were deep focus. When we say shallow focus, the focus is around 0 to 70 kilometers from the surface of the earth. Shallow focus means 0 to 70 kilometer deep. Deep focus means 300 to 700 kilometer deep. Okay, if you want, you can write those numbers. Shallow focus 0 to 700 kilometer, 0 to 70 kilometer deep. That is a shallow focus earthquake. So the focus is around 0 to 70 kilometer from the surface of the earth. Shallow focus. And deep focus 300 to 700 kilometers deep. Okay. Right. So these were the additional observations that we had. Okay. Additional observations. Then there was one more observation. I'll tell you in a minute. But just before that, there's a question. Let me see if I have to answer. Is there a criteria to define the age of rocks in continent? There is. That is done by carbon dating and all. We won't get into that. Okay. Please do it yourself. Not needed. Okay. And one more request again and again, which we have been making in the last classes also. Please send your doubts to the coordinators. The relevant doubts the coordinators will send to me. If you keep sending the doubts, then the speed of the class becomes slow and we will not be able to go fast. Okay. So then it becomes boring for many. So please send your doubts to the coordinators. Shravan, please send it to the coordinators. Okay. And then if needed, they will send it to me wherever they need a help. Otherwise, they would be answering. They are pretty competent people, right? All the coordinators who are coordinating your classes, they themselves are pretty much knowledgeable about this exam. Okay. They have already cleared different phases of this exam. Okay. So I have seen coordinators who are already selected, right? And they are also for improvement, they are appearing, and side by side, they are doing the coordination work of the classes sometimes. So please have faith, right? And please send your doubts to the coordinators. If needed, they will send it to me, right? That will also help in ensuring that the class speed remains good. Okay. So right. So the oldest age we have seen was the trench and all. Now there is one last observation that we had made with respect to this, which I have to make you understand. Okay. Your NCERT says polarity, magnetic polarity of the rocks, right? They have stated this magnetic polarity, but many of you would not just by reading that statement understand what it means. So I have to make you understand what do we mean by magnetic polarity of the rocks. Okay. So you can write this statement. You can first write the statement that when the magnetic polarity of the rock, this is also an observation, when the magnetic polarity of the rocks were checked magnetic polarity of the rocks were checked on the ocean floor, it was found that the rocks near the central fault, has normal present day magnetic polarity, Rocks near the central fault had present day normal magnetic polarity, and after that alternate bands alternate bands alternate bands of magnetic polarity were found alternate bands of rocks of magnetic polarity between normal and reverse. Rather, write this way: alternate bands of rocks of magnetic polarity reverse and normal. Magnetic polarity reverse and normal were found. As shown. And please do draw this diagram. Right? So the blue color is reverse magnetic polarity, red one is normal magnetic polarity. So when we took the rocks from these regions, we found that the rocks which were near the central fault, they had the normal magnetic polarity, normal present day magnetic polarity, right? Whereas the one just next to it, right? There was a band of rocks having reverse magnetic polarity. The whole crust was like that. Band of rock having reverse magnetic polarity. Something like this. After that, again, another band of normal polarity and another band of reverse polarity. So alternating bands then we found like this. Okay. What does this polarity mean? I'll explain, don't worry. So just draw the diagram to show the normal polarity and reverse polarity rocks. Something like this. Okay, Spider-Man color ban gaya. Okay, alternate bands of red and blue. ठीक है, so something like this. Right. So normal magnetic polarity rocks, normal magnetic polarity rocks and reverse magnetic polarity rocks. Okay. So once we understand this, now let us try to understand the next part, should we? So once we understand that this is what we found. Now what is normal and what is normal and reverse polarity rocks? What are, not is, what are normal and reverse polarity rocks? Okay, let us try to understand. So please see here. Now all of us know that this is the earth. Okay, and we also know that we have the geographical north, GN is geographical north pole and geographical south pole, like this, Arctic and Antarctic, Arctic and Antarctic. So Antarctic we call presently geographical south pole in Antarctic and geographical north pole in Arctic. We also know that Earth's present magnetic polarity, Earth's present magnetic polarity is like magnetic south pole there and magnetic north pole here. Magnetic north pole, magnetic south pole is like this. Okay, this is present, right? So red one is present magnetic polarity, also called, please do write, present magnetic polarity, also called normal magnetic polarity. Now why do we call it as normal? Just because presently we have this, therefore we are calling it as present. There is no other logic. We could have called it as reverse also, but we are saying the present thing as reverse. So we are then in that case the previous thing we would have to call as normal. So we call this present magnetic polarity of the earth as the normal magnetic polarity, because in our lifetime we are finding this. So whatever we are finding in our lifetime, we are calling that as normal. Okay? Is this okay? Right? For example, the children who would have, got some senses after this COVID, once the COVID started. Okay, so in the year, let's say a child got some sense after he was born, so he came to his senses, or he became something like 2-3 years old or 4 years when he could understand things. And the moment he started understanding things, COVID was around and people were moving around with masks. So people with mask will be his normal. Okay, for us, people with mask is not normal. But for such children who are born in the last few years, for them people with mask will be normal. Okay. So same ways, for us this is the normal magnetic polarity. Now why are we calling this as normal? Because we also know that after a few lakh years, this polarity might reverse and we might get a polarity in a different, just to keep clarity in the diagram, I'm drawing it on the other side. It's not necessary to get on the other side. It might be just this along this red line. But if I draw only along this red line, it might get confusing to see. So I'm just drawing it slightly separate, right? So then we might get this as magnetic north pole and this one becomes magnetic south pole, right? So what is this? Polarity after or before, next or last reversal. Everyone knows magnetic polarity reverses on the earth. We have already discussed this. So this blue thing is the polarity which we might have had, which we had in the past, or which we will have in the future. Okay, when the polarity reverses. So reversal, and hence also called reversed polarity. So normal polarity and reverse polarity. I hope this we understand. This one is normal, red one, and this one is reverse. So we know, do we have to draw this too? Yes, you have to. मतलब क्या चाहते हो? हाँ, what should I ask? क्या चाहते हो लाइफ में? सर आप ड्रॉ करके घर पे भिजवा दो. थोड़ा वर्क तो करेंगे ना मृगांक. ओके, सो ऑलराइट, सो आई नो ऑल ऑफ यू आर सिटिंग एट होम कोजी, है ना, कुछ मजे से बैठे हैं. तो सर कौन, हु विल वर्क हार्ड, but you have to do. Okay, so come back. So we have this magnetic normal polarity where north pole is here and south pole is there, and magnetic reverse polarity where south pole is this side near the geographical south and north pole is where the geographical north is there. Okay, and we know that this keeps reversing, right? This is a reversing phenomena, so it keeps reversing. So we will have alternative, right, switching. So every lakh years it will remain like this, then switch, then again switch after few lakh, and this, switching keeps happening, oscillation keeps happening. Now, what happens to the rocks in this period? Now, please understand what happens to the rocks. The rocks, let us say some volcanic eruptions happen during this period. So the rocks that will come out, and let us say the rocks which are coming out, they also have some magnetic character, right? So when we had one type of polarity, at that time, whatever volcanic eruption happened, let us say during that volcanic eruption, magnetic rocks came out. So they will align themselves in the direction of magnetic field. Okay, so the rocks that will come out during this period, okay, the rocks that will come out during this reddish period will try to, let us say at this place B, we had a volcanic eruption. Okay. So at place B, we had volcanic eruption and rocks came out. So they will align themselves. Magnetic rock came out. So they will align themselves like this. Right? Just like a free magnet aligns itself. Why the reverser? फिर से राहुल कितना दिन बाद उठे हो आज क्लास में? When we did magnetism of the earth, I told you magnetic reversal happens. We don't know the cause. तो फिर से वही सर, वाई दे रिवर्स. थोड़ा सा रिवाइज करिए, ऑल ऑफ यू प्लीज डू रिवाइज व्हाट वी आर डूइंग इन द क्लास. ऐसा एकदम सो के नहीं उठना है. ज्योग्राफी डजंट हैपन सो के उठ के सीधा क्लास में आ गए, कुछ पढ़ा वढ़ा नहीं, है ना, एंड देन यू थिंक ज्योग्राफी हो जाएगा. ज्योग्राफी इज नॉट लाइक हिस्ट्री. ठीक है, कि कभी भी कुछ भी हो सकता है. ज्योग्राफी में थिंग्स हैपन एज पर लॉजिक. ठीक है, यहाँ कोई इन्वेडर जबरदस्ती नहीं आता है. ठीक है, कि सब कुछ ठीक चल रहा है, इन्वेडर घुस गया. Alright, so in geography you have to understand logic of things. Okay, so whatever we have done in the past is required for future classes also, right? So please do revise those things. And I have said please don't ask doubts here, especially these aisa wala doubts. Okay, why magnetic reversal? Please send all these doubts to the coordinators. If needed, they will send it to me. I'm saying this again and again. Okay, so the rocks which will come out of volcanic eruption at this time, they will try to align themselves in this direction. Okay, and the rocks, let us say after few lakh years we had a magnetic reversal, right? So once we had magnetic reversal of the earth, magnetic reversal on the earth took place. Now, and let us say now at some other place, location C, let us say at location C we had a volcanic eruption. So now the material that will come out at this place will align itself. Okay, the magnetic rocks which might come out of the eruption will align themselves like this. So now if you go to this place, you will find the rocks aligning this way, magnetically aligning this way. Whereas if we go to location C, we will find that the rocks at location C are aligning themselves magnetically like this. So this is what we call as magnetic polarity of the rocks, or rock polarity. Okay, so rock polarity means this, that rocks which came out of volcanic eruption during that given magnetic phase of the earth, magnetic polarity phase of the earth will align itself according to that. Okay, so I hope you understand this is, so this red one becomes what? Red one becomes normal polarity, right? Normal polarity rocks we can write. Normal polarity rocks, and the blue ones we can call reverse polarity rocks. Okay, right? So okay, so is this okay? So some of you have said, sir, please don't take irrelevant questions. It saves time. I can and I would, but actually if I don't read these, then many of you would say, sir तो सुनता ही नहीं है हमारा क्लास में, sir does not respond, है ना? वो भी तो आप ही लोग करते हो ना, है ना? You will send and tell, sir does not listen to anything that we say in the class, है ना? He does not respond. So then you have to, you have to listen to what I'm telling. Please send the doubts to the relevant place. Okay? Right? Gradually, you also have to start learning how to, learn in these online modes. Okay. Get gradually used to all this, because these online modes are going to increase in times to come, because this is also becoming a very effective way of teaching and understanding. And many of you will get access to, many international programs and other things gradually thanks to this. Do you get it? So I would say that you should also get used to of how we have to learn and behave on these online modes, right? In years to come also this will help. All right. The newer generation is doing a lot of this, right? My daughter is doing, for example, my child, if I tell you, so she is doing some painting classes from international painters outside India. She's also doing some programs for her, analytical skills and all, from again some very renowned online programs available outside India also. So online, once you adjust, but then you have to learn the etiquettes of all those online classes. Okay, so please start getting adjusted to these modes. They will help you. Okay, don't think this as a random thing. This is not a random thing. This is going to stay for years to come. Okay, so not because of COVID, but even otherwise, because that gets you access to much better quality, people and networks, etc. Right? So let us come back. So I hope you understand this. So normal polarity and reverse polarity. I hope we get this. Okay? Is this clear? Broadly clear? So now, so once we get this reverse polarity rocks and this thing, the same is visible when we see here. Now, when we went to the oceans, there what did we find? We found long bands on the ocean floor, right? So first, near this, we found near the central fault, we found the present polarity rocks, right? Present polarity rock bands on the floor. The whole rocks were made up of present polarity material, because we know that at the mid-oceanic ridge, continuous volcanic eruption is taking place, and it is taking place for millions of years. Okay. So in that, many magnetic reversals would have happened. So we find here normal polarity, next to it older, next to it reverse polarity, next to it again normal polarity, after that again reverse polarity, and so on. So this is what we found. Is this clear? Okay. Is this clear? Right. So you can write down a few lines about this. That this one, what is normal and reverse polarity? That write down. Normal polarity, normal and reverse polarity. Under that write down. What is normal and reverse polarity rocks? Write down there. We know that magnetic fields, Earth's magnetic fields reverse, Earth's magnetic fields reverse after Earth's magnetic field reverses after every few lakh years. Magnetic field reverse after every few lakh years. Full stop. We also call the present magnetic polarity of the Earth as normal magnetic polarity. We also call the present polarity of the Earth we call the present magnetic polarity of the Earth as normal magnetic polarity, and the previous polarity. So present we call as normal and the previous polarity as reverse polarity. The immediately previous polarity, not all, but immediately previous polarity as reverse polarity. As reverse polarity. Full stop. We also know we also know that volcanic eruptions continue to take place. Volcanic eruptions continue to take place on the Earth. Volcanic eruptions continue to take place on the Earth continuously. Hence, the magnetic rocks, magnetic, MAGNETIC, magnetic rocks which come out, magnetic rocks which come out during different polarity periods, magnetic rocks which come out during different polarity periods, which come out during different polarity periods tend to come out during different polarity periods tend to align themselves as per the polarity of that time, as per the polarity of that time. As per the polarity of that time. For example, the rocks that would erupt, during rocks that would erupt during normal magnetic polarity period, normal magnetic polarity period, normal magnetic polarity period will magnetically align as per the normal polarity, magnetically align as per the normal polarity, and you can write within bracket, right, rocks, normal polarity rocks at location B in the diagram. This one, normal polarity rocks at location B in the diagram. Normal polarity rocks at location B in the diagram. Normal polarity rocks at location B in the diagram. Bracket close. Whereas magnetic rocks that will form during reverse polarity period of the earth, magnetic rocks that will form during reverse polarity period of the earth will align in the reverse, will align magnetically in the reverse polarity direction. Reverse polarity direction. Within bracket, blue colored rocks, this blue colored rocks. Okay, so now you say which one you are saying. Blue colored rocks at location C in the diagram. Okay, so this is what your magnetic polarity of the rocks mean. Now come to the ocean floor. So in the ocean floor case, we found alternate bands. Starting with normal polarity. We found alternate bands starting with normal polarity rocks near central fault. Starting with normal polarity rocks near central fault as shown. As shown. Okay, good enough. So these are all the observations that we had with respect to the seafloor. Clear? Right? Now, next. So once we understand this, then you can write next paragraph. Based on all these observations, in 1961, based on all these observations, comma, in 1961, Harry Hess gave a theory to explain, gave a complete theory to explain all these characteristics and observations. To explain all these characteristics and observations, called as the sea floor spreading theory, known as the sea floor spreading theory. Sea floor spreading theory, as explained below. as explained below. Okay. So what does this theory say? Please let us try to say. See. Now, I would want you to draw this diagram along with me. Okay. Similar to the one that we have done earlier. Okay. Right. And in this, I'm drawing something more. Please see, focus, and draw. Okay. So the diagram is complete. Now I'll draw the parts of this. I'll name or label the parts of this diagram. Hopefully all of you can see this and keep drawing. Okay. So we have the central fault and the MOR, oceanic crust or lithosphere, and the trench, right? So oceanic crust or the lithosphere is here, also called as sea floor. Sea floor, oceanic crust or lithosphere, it's the same. Then we have the asthenosphere and convections in asthenosphere. Convections in asthenosphere. Okay. And some of this magma was rising and erupting and solidifying. Right? Volcanic eruption. So that red colored thing is the volcanic eruption happening. Okay, good. So now once we have drawn this, then we have to write. What is the name of this diagram? Sea floor spreading as per Harry Hess theory. This is sea floor spreading as per Harry Hess theory. All right. So once you have drawn, then write down. Harry Hess, I'll go on dictating slow. The ones who are still drawing some parts can gradually complete. Harry Hess stated that the oceanic crust or lithosphere, comma, the top of which we call as sea floor, oceanic crust or lithosphere, this whole thing we call as the oceanic crust or the lithosphere, and the top of this we call as sea floor, the top of which we call as sea floor keeps spreading away, driven by drawing the arrows of the spreading away. You can see, keep spreading away. This one goes this way, this one goes this way. Keep spreading away, driven by the away moving parts of the asthenosphere convection. Driven by the away moving parts, this ones, away moving parts of the asthenosphere convection, these ones, away moving parts of the asthenosphere convection. Full stop. Due to this, some basaltic magma, right this way, some basaltic magma of the asthenosphere, continuously erupts where the lithospheres are diverging, where the two parts of the lithosphere, this part and this part, where the two parts of the lithosphere are diverging, continuously erupts where the two parts of the lithosphere are continuously diverging. This place continuously erupts. and leads to formation of continuously erupts where the two lithospheres are diverging, comma, erupting at the central fault, erupting at the central fault, and continuously solidifying, erupting at the central fault, erupting at the central fault and continuously forming, continuously forming the mid-oceanic ridges, continuously forming the mid-oceanic ridges on both the sides of the central fault, mid-oceanic ridges on both the sides of the central fault, due to solidification, due to solidification of the magma, due to solidification of the erupting magma. Solidification of the erupting magma. Full stop. Solidification of the erupting magma. Full stop. All this while, the divergence spreading away, divergence within brackets spreading, divergence causes divergence of the lithosphere, right this way. All this while, divergence of the lithosphere causes spreading away, of the seafloor, spreading away of the seafloor causes spreading away of the seafloor as newer part of the MOR, newer part of the MOR continues to form, newer part of the MOR continues to form, and older parts continue to diverge away, hence forming newer sea floor continuously, hence forming newer sea floor or oceanic lithosphere, forming newer sea floor or oceanic lithosphere continuously. Full stop. Simply said, simply said the continuous volcanism at central fault, simply said the continuous volcanism at central fault continuously forms new rocks, and MOR continuously forms new rocks and MOR, comma, and simultaneously the diverging asthenosphere, this one, diverging asthenosphere continuously spreads the seafloor by taking away the rocks from MOR. Taking away the rocks from MOR. Taking away the rocks from MOR, comma, this way new oceanic lithosphere is continuously formed. Full stop. The spread part of the seafloor, then sinks back. The spread part of the seafloor then sinks back into the asthenosphere, at the trenches, as shown in the figure. So this is how on one hand new oceanic lithosphere, on one hand new oceanic lithosphere is formed at the MOR, whereas oldest oceanic lithosphere sinks back into the asthenosphere at the trenches. Sinks back into the asthenosphere in the trenches. Sinks back into the trenches. Full stop. Harry Hess also stated that this whole process does not take more than 200 million years. 200 million years. From the starting of the formation. From the starting of the formation to the end. To the end. And this is why on the ocean floor, we nowhere find rocks older than 200 million years. Nowhere find rocks older than 200 million years. As the whole cycle of ocean floor formation, does not take more than this time. Does not take more than $200 million years. Okay, so this is your whole cycle of the formation. Now we will talk of the other characteristics that we have seen. So we will try to justify all the observations that we have made as per this, right, in a moment. Just before that, there are some doubts on the board that, sir, what is the period of this theory? Britannica, Encyclopedia Britannica says 1960. 1960 is right as per Savinder Singh. Go as per NCERT, which is 1961. Okay, so if you see different sources, right, for this theory, they give you, different aspects about this theory. For example, if you see the Wikipedia, it will say 1960s. All right, the name of the scholar also, complete name is given as Harold Hess. Okay, and all. If you see Britannica, it will give you 1960, 1960s, 60S is given in this thing. Your NCERT says 1961. Savinder Singh does say 1960. So for the theories, for the geography optional people, if the same question comes, seafloor spreading has been asked lot many times, right? So if the same question comes, I would say you go with Savinder Singh. Okay, if you see Stoller and other books, you will find Hamlin and all, you will find similar dates, right, ranging. Some say 60, some say 60, some say 61. So, but for the ones who are going as per the NCERT, UPSC, GS, NCERT is your book. So if you write 1961, they will not deduct marks for that. Okay, they will rather be okay. Okay, if you write 60, then it shows that you have read other books. Maybe you are a geography optional student. And it is always good to show that you don't know much about optionals. Right, in your GS papers, you should not show your optional background. Okay, so please refrain from showing optional background or optional content in GS papers. Still, if you feel like, I would not stop, you write whatever you feel like. Okay, I have been telling, because in my optional this thing, I keep telling 1960s, I give the whole name, but in your GS, I only give you this much, right? So I would expect you to go with what I'm saying. If you still want to modify and you can write as per Britannica 1960, I would say they won't cut your marks. Even if you say, but don't mention as per Wikipedia. That won't get you marks, right? That is a negative thing. All right. So let us not go on discussing this. these small discussions can continue for long. This way in UPSC preparation, for every point you will find 10 different explanations. Okay, so you have to stick to something one, and NCERT is your best source for this exam as far as GS is concerned. Optional, I won't discuss anything with respect to optional or from the optional perspective in these classes. Okay, so let us come back. So now, so ocean floor still creating in MOR and destroying in trench. Perfectly fine. Yes. Okay. So now write down. Hence, next write down. Hence, all the observations, made after the Second World War about the ocean floor, all the observations made after the Second World War about the ocean floor can be justified as per this theory, like volcanic eruptions at the MOR, newest rocks at the near the MOR, newest rocks near the MOR, gradually getting older towards the trench, oldest rocks at the trench, similarity of rocks, on both sides at equal distance, similarity of rocks on both sides at equal distance. Nowhere sediments older than 200 million years found, because the lithosphere itself was subducting. Okay. So nowhere sediments older than 200 million years found. Okay, comma, and finally, even the magnetic reversal and related normal and reverse polarity rock bands could be explained as per this theory, this one, right? So newest eruption here, present eruption here, so present polarity here, and as you go away, these rocks might have been formed a few lakh years earlier on both the sides, so they have a reverse polarity. The ones before them might have been formed another few lakh years earlier, so maybe reverse to reverse, that is again normal polarity, and so on, right? So alternate bands. Okay, so all the observations made in the post Second World War period were explained by Harry Hess theory. Okay, as we can see here. Is this clear? Yes or no? Please let me know. Is this much clear? Any major doubt? Now I ask you, if there is any major doubt, ask me. Right? Small doubts you can generally send to your coordinators. Broadly, do all of us understand this or not? Is this much broadly clear to all of us? You can keep sending your doubts to the coordinators. They can keep sending it to me if needed. But is this much broadly clear to all of us? Yes or no? Yes, sir. As I said, minor doubts would always remain. So if this much is clear, angle between geographical axis and magnetic axis also changes or not? Yes, it does. Fine, good, good. So it shows that most of us are broadly clear with what we have done, right? Now you can write some weaknesses of this theory. Weaknesses, please do write some weaknesses of this theory. Very good. Good to see everyone is clear. So some weaknesses of this theory. Magnetic polarity, please re-watch that part of the video. Sumit, you will understand, don't worry. Okay, watch the part of the magnetic thing that we did earlier and then re-watch, you will get. Right, good. So now weaknesses of this theory, you can write that Harry, the seafloor spreading theory does not discuss much about this. The seafloor spreading does not much discuss about other formations like ridges, islands, does not discuss much about other formations like ridges, islands, etc. Second, it also does not discuss about continent formations and movements. Continent formation and movements. Right. So these are some of the weaknesses of this theory. Right. But it was the first theory, seafloor spreading theory. Seafloor spreading theory was the first theory. This is the good thing about this theory. It was the first theory to broadly explain major characteristics and formation of the ocean floor. Major characteristic and formation of the ocean floor. Okay. Then, so with this we come to the end of this now seafloor spreading theory. Now, you can write this in 1967. In 1967, a new theory. 1967, a new theory known as 1967, a new theory known as the plate tectonic theory. Plate tectonic theory was proposed by different scholars. Plate tectonic theory was proposed by different scholars, which went on to answer many previously unanswered questions. And went on to explain many previously unanswered questions and comprehensively explain continent and ocean floor formation, along with many other major and minor formations. Okay, so what is the name? Plate tectonic theory. Okay, so this we have to do now. But before I start with this, I will give you a quick 15-minute break here. Okay. So let us take a quick 15-minute break and let us meet after the break, right? And then we'll start with this, right? So let us take a 15-minute break here and then we meet. All right. Technical team, मैं mic off कर रहा हूँ. Thank you. Okay. So a lot of short about group. Okay. And also about the class seems to be slow paced. All right. And still there are people who keep asking doubts about much sillier doubts. Okay. Sillier as in very simple, I should say, showing less revision. Now, as far as the pace of the class is concerned, I would recommend don't worry. Okay, this is the pace at which we have been doing most of the batches. And in every batch, we have been able to complete. And in every batch, people have been able to benefit and clear the exam. So you should also. Okay, so don't worry about that pace. Okay, and just focus on understanding. And if you find time, let us say if you feel that we are going slightly slow, you can keep your next other geography, NCRT or any other thing side by side and keep reading it. ठीक है, वो भी पढ़ लो, देखते हैं. ठीक है, maybe you can increase your pace this way, right? Just give me a moment. I need to ask them to fix up this. Okay, so audible, yeah. Some voltage fluctuation problem because no power since last night. But anyways, we'll sort it out. So There's one more thing I would say here, right? I see a lot of conversation happening on these chat groups. So coordinators, please block the chat group for the time being, right? Because they have made it, I don't think you people are understanding the importance of this chat group. Okay. This is a student response portal. Don't make it a normal chat group. This is not your WhatsApp. Okay. So please write your difficulties and doubts to the coordinators and stop doing all the other conversations. Otherwise, we might have to block you. Okay. I see a lot of, there are so many chats which are happening for no reason and for, I should say, unfounded doubts that you have in your mind. ठीक है, इस स्पीड से ये होगा वो होगा, all that is rubbish, let me tell you. Okay, so just stop all that rubbish chat that you are doing for the time being. Don't, and just go with the class. If you feel like this is perfectly fine, this is how the class would go, right? At least from my end. ठीक है, तो आप लोग आराम से क्लास करो एंड बी देयर, शांति से अटेंड करिए एंड 100% बी श्योर दिस इज नॉट योर माय फर्स्ट बैच. आई हैव डन at more than 50-60 batches till now. Okay, more than that. Okay, so don't worry. And from every batch we are getting selections, right? तो ऐसा कुछ भी नहीं है कि आप लोग कुछ बिल्कुल ही अलग टाइप के बच्चे हैं. ठीक है, so just be at the pace that we are doing. Attend the class and keep doing your task. The task that I ask you to do, all of you I expect you to do. ठीक है, तो वो करिए, बाकी सारी कहानी छोड़ दीजिए, शांति से बैठिए. ठीक है, and let us continue with the next topic. Okay, so the next topic that we have is your plate tectonic thing, right? Let us continue with plate tectonic, right? So the plate tectonic theory, I have to make you understand a bit, and obviously there would be at times technical difficulties here and there which I can't solve, right? जैसा अभी कोई लिख रहा था सर 23 मिनट हो गया ब्रेक को, अब टेक्निकल डिफिकल्टी क्या कर सकते हैं, क्लास कैंसिल हो सकती है उसके लिए तो. ठीक है, I can't stop. Right? At least we are doing your class. Many other institutes I have seen through these COVID times, institute ही बंद था. ठीक है, so if the classes are going, everything is happening. Obviously, मतलब ऐसा special behavior नहीं दिखाना है ना that you are very special students. IAS का तैयारी कर रहे हो, ठीक है, work at your end and things would happen, and be ready to take things in your stride rather than showing disappointment at everything. Right? It won't happen that way. Right? So that's okay. Technical difficulties, as I said, it would always happen. There have been times in batches we have been able to, not conduct classes for 2-3 days. नहीं है power, क्या कर सकते हैं, नहीं हो रहा है, system connect नहीं हो रहा है, lot many things. ठीक है, so cool. ये नहीं कि इसका chat box ही बना दो और बिल्कुल जबरदस्ती का conversation किए जा रहे हैं. So that doesn't, I have to neglect at some point. Right. So yes, now let us come back to our task and let us come back to this topic of plate tectonics. Let us try to understand what do we mean by plate tectonics and all. So till now what we understood is that there's a lithosphere region on the Earth's top, which is the rocky layer. Okay, and below that we have the asthenosphere, and in the asthenosphere we have convections. Okay, so the convections which are taking place in that asthenosphere region, they go on to move the lithosphere. And because of that, as we saw in the seafloor spreading thing, that at some places magma come out, and that is where the central fault is formed, and on both the sides, all that story. Okay. Now, what does the plate tectonic theory tell us? Let us try to focus on this. So when you talk of this plate tectonic theory, the plate tectonic theory basically goes beyond all the previous theories of its times and went on to tell us more aspects about this whole, formation of lithosphere and different other formations that we have. And as I have already said, also explained the other major and minor formations not taken up earlier. Okay. So what did the plate tectonic theory finally said? I'll have to draw the diagram. I'm just trying to connect, as you can see, right? Once connected, I'll show you the diagram, and I would expect all of you to draw along with me. So what did this theory say was that the previous theories stated that the lithosphere, please do write this in your copy. The previous theories stated that the lithosphere was one hard rocky shell over the asthenosphere region, right? Like the shell of the egg, like the shell of the egg, right? So just imagine this was your Earth. So just the way the shell of the egg is there on the egg, same ways the lithosphere is there on this, okay, shell of the egg. But the plate tectonic theory states, that the lithosphere is rather broken. The lithosphere is rather broken. Lithosphere is rather broken at many places. Lithosphere is rather broken at many places and into pieces, like the broken pieces of the eggshell. Like the broken pieces of the eggshell. Right? So if you take the egg and you crack the shell, so you'll have broken pieces on it like that, as shown. So something like this. Right? Like the broken pieces of the eggshell. Also, there might be big pieces and small pieces of the lithosphere. Might be big pieces or small pieces of the lithosphere. You can see here. So you have these bigger pieces and you also have these smaller pieces of the lithosphere. All of these are called as plates. All of these are called as plates. And hence, all of these are called as plates, and hence plates can be of major and plates can be of bigger size, known as major plates. Hence, plates can be of bigger size, known as major plates. All smaller size, known as minor plates. So simply said, simply said, as per plate tectonic theory, the lithosphere of the earth is broken into major and minor plates. Lithosphere of the earth is broken into major and minor plates. Major and minor plates. where there are around 7 major plates, where there are around 7 major plates and numerous minor plates, 7 major plates and numerous minor plates. As shown below, as given below, because we won't be drawing, but as given below. Okay, so which are the plates? Please see here, as given below. So which are the plates? See here. We have 7 major plates. As you can see, first of all, now I want all of you to focus on this diagram. Okay, so as to understand, otherwise you will go on asking the same question again later on. Let's say what is this, what is that? So please focus, right, and listen carefully, right? Rather than being too much occupied with, sir, ये नहीं हो रहा है, वो नहीं हो रहा है, ठीक है, या group बनाओ, WhatsApp group. This has happened, right? I have seen this happening for the last 3-4 years, right? Students go on forming group. After a time, the group will be gone, right? And all that. So it doesn't work. Your focus in the class, as long as you are in the class, those 3 hours, you should be on this class, listening to what the teacher is saying, right? And focusing. अगर आपको मतलब समझ में आ रहा है तो good enough. And people, I have said so many times, and I know for myself that so many batches we have done and so many students have got selected. So there is no reason why you should not if you focus. Right? We go on incorporating whatever is new and everything. We know the pace. I know the course will be completed. Even if it takes me 3-4 more classes here and there, I will do and complete. Okay, so don't worry about course complete होगा नहीं होगा, notes बहुत बन रहा है. Some of you say notes बन रहा है, कोई बोलता है नहीं बन रहा है. I can't go on listening to each of you. Right, so we have already formed the standardization of the class, which we conduct, which I would conduct, and everything needed will be there. So you just focus on that. And the ones who still want to do extra chat, you are always free to do it. No one can stop you. Right, so go on creating groups, be on Facebook, Twitter, जो बनाना है बनाओ. ठीक है, doesn't matter. But as long as you are in my class, please focus. Right, so that you don't ask questions which are very, very, repetitive and very, very basic again and again. Okay, so focus in the class. Focus should be the only thing that I expect from you. And this is what I find lacking many times from the questions that come to me. That you are not focusing, you are not revising, you are spending your time elsewhere. Go on doing it. I can't stop you. No one can stop you. I told you in the very beginning, all of you have the potential, but hardly many of you will make it through this exam. The reason is lack of focus. Okay. So this is all I want to say, right? Why Vision doesn't create a WhatsApp group for you in the very beginning? We could do it now, very easy. But we know that much of the chat happening on those groups is rubbish, useless chats, right? You don't discuss these questions amongst yourself. You discuss this, all kind of awkward things, which doesn't add up to anything, right? So if you have any real doubts, you can put on this portal. You can ask your coordinators, you can show the answers. ठीक है, वो सब करिए rather than trying to figure out the speed of the class and all. As I have said this earlier also, I believe in your batch that your course will be completed in time. Don't worry. आपका course batch अभी start हो रहा है, बहुत सारा batch अभी नवंबर में start होगा. Those will also be completed. तो आपका बैच तो होगा ही होगा और अभी होगा and on time होगा. Don't worry. ठीक है? So just focus. So come back and please look into this diagram because this is a very different diagram. You might not have seen this kind of a diagram earlier. What does this diagram show you is that in the background you can see some continents. Not see some continents, you can see all the continents. But the placement of this map is different. How? In this map you find North America and South America in the center. Okay? And on that side, eastern side you see Africa. Don't ask me, sir, how? Because Earth is round, so you can look at any continent keeping that in the center. Okay, so North America and South America, east of that is Africa and Europe. And in this map, as you can see, this is North and South America. So west side we have Asia. This is Asia and this is Australia. Is this much clear? Why? Because we are looking at the globe from the keeping North America in the center in this map. Okay, so you can see these continents: Asia, Australia, South America, North America, that is Greenland. This side is Africa. At the end, you see India, that reddish color thing, and above that is Europe. Clear? But this map is not showing you continents. It is showing you something more. What is that? You can see different color blocks. For example, you can see the South American block as one color. You can see this block as one color, Pacific block. You can see this Australian block along with Australia and the parts of the ocean. Obviously, what is there beyond the continents? It is the oceans. So with this part of Pacific and all, this is one color. You can see this one as one color, right? Each of them, Africa and the surrounding oceans as one color. So every one color block is one plate in this diagram, right? So whole of the earth is divided into plates, right? And every one color block is one plate. That one plate is having on its continental crusts, right? As well as oceanic crust also. So this region is oceanic crust. This region is oceanic crust. This is continental crust. You can see. And this whole thing is one plate. This whole thing is one plate. Is this clear? Right? So in this you see different plates. So how many plates and colored blocks do you see in this? If you start from Eurasian. So for that Eurasian region, whole of the region, you have one. So I'll number, right? So this is Eurasian that side, and obviously it continues. So this side also you find the same Eurasian as number one. So Eurasian is one plate, right? One big plate is your Eurasian plate. Then the second big plate between Eurasian is North American plate. You can see North American plate, that is plate number 2. Okay. So if you see the whole globe, you are looking at the map like this. North America in the center, this side Asia and Australia, okay, and the other side you have South Africa. Can you see? If you keep North America like this, you get to see it somewhat like this. Clear? So now then the third big plate that you see here is your Pacific plate, third big plate. So first big plate, Eurasian plate. Second big plate, North American plate. Third big plate, Eurasian plate. Pacific plate. The fourth big plate, you can write here, Australian plate. Australian, which is also carrying part of India. Okay. So Australian plate along with part of India is your, we call it as Indo-Australian plate. Your NCERT calls this as Indo-Australian plate. Okay. So we have the Indo-Australian plate as your fourth plate. Then the fifth plate we have is the Antarctic plate. At the bottom, you can see continuous plate on which Antarctic continent is there and part of the ocean is also there. Oceanic crust is also there. So Antarctic plate, 5. Then the sixth plate, South American plate. Okay. And the seventh major plate is the African plate. So on the African plate, you have the Africa continent, and on the sides of it, you also have the oceanic crust. South American plate also, you have South America continent and you have the parts of Pacific crust. So this way you have these 7 major plates. These are your 7 major plates. Is it clear? Right? And then you have some minor plates also shown in this diagram. If you start from one corner, for example, you can see here the Arabian plate. Okay. And all these plates, I'm giving you only the ones which are broadly there in your NCERT. I'm not giving you beyond that. So Arabian plate, Scotia plate, a small plate here, Nazca plate, okay, Cocos, and I want you to write down these names. Okay, so you can write the 7 major plates. First write down the 7 major plates are, the ones who have written good enough, the ones who have not written can write. The 7 major plates are as given here: Eurasian, North America, Eurasian plate, North America plate, Pacific plate, North America, Pacific, Indo-Australian plate. You write this way because your NCERT gives the name as Indo-Australian plate as one plate. Indo-Australian plate, Antarctic plate, South America plate, South American plate, South American plate, and African plate. Full stop. Next line. There are numerous minor plates, many of which are still unknown to us. We don't still know many of the minor plates. There are numerous minor plates, many of which are still unknown to us. Still unknown to us. Some of the important minor plates include Arabian plate, Scotia plate, Scotia, Scotia plate, Caribbean plate, Nazca plate, Cocos plate, COCOS, Cocos, Juan de Fuca plate, right? Juan de Fuca plate, Philippines plate, JUAN, Juan de Fuca, Fuca, Juan de Fuca plate, Philippines plate. Then write Caroline plate, Caroline plate, Caroline plate. Caroline plate lies somewhere here. Okay, so in this region we have the Caroline plate and the Fuji plate, which is northeast of Australia. Fuji plate. Okay, so these are the major and minor plates that we have. Hopefully we understand this. Right? So once we understand the major and minor plates, right? So you can write the above major and minor plate classification, was on the basis of size. Was on the basis of size. Was on the basis of ठीक है तो स्विच कर सकते हैं Classification A, on the basis of size we have major and minor plates. Okay, so this one we have done. Next. Now there are other classifications also. This one we have already done, major and minor plate. Okay. So then write down there are other classification of the plates also. There are other classification of the plates also. For example, the NCERT classification. I will give this because this is given in the NCERT. Okay, NCERT classification on the basis of, do write down, on the basis of NCERT classification, on the basis of major part, or please do write major part or major continent, major part or major continent on the plate, on the plate. NCERT classification on the basis of major part dash major continent, major part dash or major continent on the plate. Right, where you have written major part, right? Major crust part. Okay, major crust part, major crust part or major continent on the plate. Full stop. Then write down, this classification depends on, this classification depends on whether, this classification depends on whether there is a major continental crust on the plate, there is a major continental crust on the plate, or major oceanic crust on the plate. Major continental crust on the plate or major oceanic crust on the plate. For example, all the major, all the plates, you write, for example, all the plates containing major continents on them, containing major continents on them are called as continental plates, are called as continental plates as per this classification, are called as continental plates as per this classification. Such as South American plate, North American plate, South American plate, North American plate, African plate, South American, North American, African plate, Eurasian plate, Eurasian plate, Antarctic plate, Antarctic plate, and Indo-Australian plate are all continental plates as per this theory. Are all continental plates. Are all continental plates. Why? Because they have major continents on them. Are all continental plates. Comma. Whereas only Pacific plate, is a oceanic plate. Only Pacific plate is a oceanic plate as per this NCERT classification. Okay. So if you see here, for example, in South American plate, you see there is a Pacific part of the crust also on the plate, and there is the continental part of the crust also on the plate, but still we call this plate as continental plate as per this NCERT classification. Same ways, if you see this African plate, okay, this whole thing, there is African continental crust, plus it also has Pacific crust and Indian Ocean crust, but still African plate will be called as continental plate as per this classification, despite of the fact that there is oceanic crust also, right? So same ways in different continents you can see. For example, North American plate, you can see this plate is also called as continental plate as per this NCERT classification, despite of the fact that there is Atlantic crust also on it and Arctic crust also on it, but still we'll call it as the continental plate. And as per this NCERT classification, there is only one oceanic plate, which is the Pacific plate. Okay, then write down, but this classification is not very useful. This classification is not very useful in understanding plate tectonic phenomena. Not very useful in understanding plate tectonic phenomena. Okay, so this classification you have to remember only for your prelims exam. In the prelims, if they say which of the following are continental plates, right, and if they give you one or those options, then you have to go with this because this is given in your NCERT. Is this okay? Now, the most important, so this classification, as I said, is not a very useful classification. All right. Not very useful classification, but we are doing it just because it is given in the NCERT. Now, the most useful classification that we have is this C. Okay. Plates classified on the basis of crust along the margin being considered. Along the margin being considered. Margin being considered. Okay, plate classified on the basis of crust along the margin being considered. Now we know there are two types of crust, oceanic crust and continental crust. So based on the margin being considered, we have to see which type of crust is there. For example, right, example. Now please see what I mean. For example, if I have a plate like this, suppose this is plate, right, then obviously this is the margin of the plate. Everyone understands margin, right? And let us say on this plate, I have a continent here and ocean here. Okay, ocean this side. So this is the continental crust right? Continent crust, I can say, and the other one is ocean crust. Okay. So if I ask that what is the crust along this margin, right? I'll name along margin 1, and what is the type of crust along this margin 2. Okay. So I hope we can see that if we see this plate, this whole plate, along margin 1, that bluish color margin, the crust is oceanic crust. Okay. So from here we will call this plate as, seen from this side, we'll call this plate as oceanic plate. Whereas the same plate, if we see along this margin where we have continental crust, then from this margin, the same plate we will call as continental plate. Why? Because of the crust along the margin. What type of crust is there? Based on that we'll say. Okay, is this clear? Do we get it? So this is right. So same plate might become oceanic plate if we are seeing it from the margin on which the oceanic crust is there, and same plate might become continental crust depending on if we are seeing it from the margin where continental crust is there. Is this clear? Now I need this answer from you. Is this clear? Because then I'm going to ask you people a question. Is this much clear? Right? So same plate might become oceanic plate or continental plate. Right? Depending on from along which margin we are broadly trying to see it. Yes. So what is the answer? आंसर तो दे सकते हैं, आंसर भी नहीं देंगे सर, आपने बोला है नहीं बोलना है तो हम कुछ भी नहीं बोलेंगे. नाउ वॉट एवर चैट वी हैव टू डू वी विल डू ऑन द व्हाट्सएप ग्रुप. यहाँ पे हम कुछ नहीं बोलेंगे. पॉलिटिकल डिसीजन. को पॉलिटिशियन नहीं बनना है, आपको एडमिनिस्ट्रेटर बनना है. ओके, ऑल ऑफ यू हैव टू बिकम आईएएस ऑफिसर्स. Coordinators, I believe the group is not blocked from responding because I need this answer and I would be asking questions now. And I will have to wait till you start answering. Oh, chat was blocked. अच्छा, अभी done sir, no sir, chat is active. Okay, good. So ऐसा काम क्यों करते हो कि चैट ब्लॉक करना पड़े, है ना? So पार्शली क्लियर. अच्छा, अभी क्या हुआ निकुंज गुप्ता जी, क्यों पार्शली क्लियर क्यों है? I have tried to make it so simple. You have one plate. On the plate, you might have oceanic crust on one side, you might have continental crust on another side. From the continental crust side, we call it as continental plate. From the oceanic crust side, we call it as oceanic plate. Now, what is the rocket science in this? That it was partially clear. Nikunj? ऐसा तो कुछ भी नहीं है इसमें. ठीक है. So hopefully clear. Right now, let me ask you a question. If this is clear to you people, then answer this question. As you can see in this diagram, right? You can see the South American plate here, all of you. So in this South American plate, this whitish region is the margin of the plate. Okay, this is the margin. I'm drawing you the margin of the plate. Okay, so this is your South American plate, complete, right? So please, in this plate, if I ask you, please tell me, right? Hopefully all of you can see this is South American continent. This is the oceanic part. Which ocean is this? This is the Atlantic Ocean. Okay, this part is the Atlantic Ocean. This whole thing. This is the Atlantic Ocean crust, because in South America, between South America and Africa, we have Atlantic Ocean. So this is the ocean. And hence I will color or shade the margin into two colors. Okay, one is this bluish colored side, and everyone I hope understands, right? So this bluish colored side margin of this plate, and then you have the other one as the red colored margin of the plate. So my question is, from this blue colored margin, what will South American plate be called as? From this blue colored margin side, what will we call the South American plate? And from the red colored margin, what will we call the South American plate? The same plate, South American plate. From blue colored margin side, if we see, what will we call it? So you have to answer like this. Okay, blue colored margin or blue side, we call this plate as what plate? And from the red colored margin side, the South American plate, we call the plate as this plate. What will we call? I need the answers. Give me blue this and red this. I need the answer this way. Clear? दोनों आंसर चाहिए मुझे, not just one. Nazca plate is a minor plate. थोड़ा ध्यान से देखिए. I have talked only in terms of major plates. So I can see a lot of you saying blue color, oceanic plate. And continental red. Very good. Right? Hopefully we understand this. So from the blue color side, this plate will be called as oceanic plate, and from the red colored side, it will be called as continental plate. Right? Blue margin, oceanic, red margin, continental. Very good. Very good. All of you, the ones who have given this answer. Right? So I'm repeating this answer for the ones who might have given wrong answer, because I'm not able to read all the answers that you people are giving. I'm able to read most of them. So what does it say? Red color. From the red color side, it is continental plate. Right? And from the blue color side, this plate is a oceanic plate. Okay. Very good. So, and now same ways, if I ask you from this blue color side, what is the African plate? African plate from the blue color side. This much of the blue color side, the African plate will behave like what? Give the answer. Blue, African. Give me that answer. That African plate from the blue color side, what will the African plate behave like? Very good. Those answers are right. The ones that you people are giving blue, oceanic, red, continental. But from this blue colored side, what will the African plate be? From the blue color side, you can see the African plate will behave like oceanic plate. African plate, oceanic plate. Right? So from this blue color side, the African plate will start acting as oceanic plate. But when you see the NCERT explanation, right? NCERT calls African plate as continental plate. But as per this classification, from the margin side, the African plate here behave like a oceanic plate. This is what I want you to understand. Okay? Is this clear? Okay? Very good. Now, once we understand this, many answers I saw. Very good. Now, let us come back to our flow. So basically, write down further. Hence, by this classification, any plate has to be judged as continental or oceanic plate. Any plate has to be judged as continental or oceanic plate. Very good. All the answers are correct. Any plate has to be judged as continental or oceanic plate on the basis of the type of crust along its considered margin. On the basis of type of crust on the margin being considered. Why are some of you writing continental plate? Sukanya, for example, do you mean, Sukanya, that along that blue margin African plate will be called as continental plate? I hope not. Okay, so Sukanya, that is continental, it will be called as oceanic plate from that blue margin. Alright, now same ways. Now see further. Please see here. This way, if we consider two plates interacting, please do draw this diagram also. This way, if we consider two plates interacting, okay, two plates interacting along a given margin. This is the interacting margin. This we call as the interacting margin. Two plates are considered interacting. Okay, interacting margin. Then on the basis of type of crust, on the basis of type of crust on the two sides of this margin, on the basis of type of crust on the two sides, this side as well as that side of this margin, on the basis of type of crust on the two sides of this margin, the two plates will be called as continental plates or oceanic plates. The two plates will be called as continental plate or oceanic plate. Hence, along this margin, we can have three combinations of, along this margin, we can have three combination of, along this margin, we can have three combination of plate types, continental, right? So you can have plate 1 as continental because continental crust might be here, and plate 2 also as continental because along this margin you might have continent. Second, continental oceanic, because on one of the plates you might have continental crust and the other plate you might have oceanic crust. So you can have continental, continental oceanic, and third, oceanic. Okay, so if we take these two plates, then we can have these three types of possibility: continental plates along this margin, oceanic plates along the margin, or continental oceanic plate along the margin, right? Depending on the types of crust we have on either sides. Is this clear? Continental, continental, continental oceanic, oceanic, oceanic. So these are the three possibilities along any margin of the plate, right? You can write, hence, these are the three possibility of plate pair. These are the three possibility of interacting plates. You write this way. These are the three possibilities of interacting plates along any margin. Three possibility of interacting plates along any margin. Okay. For example, now please see here and tell me. Right? I would need the names in your answer if you want to give. Along this South American and African plate, this is the common margin. Okay, so along this interacting margin, what type of plate pair do I have? So you have to write South American plate, African plate. You have to write oceanic, oceanic, continental, 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 oceanic. One. And second, between the Nazca plate, I hope you understand this. Nazca plate is where South America continent is over, and this side, this is ocean. This is the Pacific Ocean. This whole thing is Pacific Ocean. Okay, this side is continent, South America continent over. This is Pacific Ocean. Nazca plate is also Pacific Ocean crust. This side also is Pacific Ocean crust. So along this Nazca plate, South American plate, what type of plate pair do I have? Right, oceanic, oceanic आप लिख रहे हैं, but I don't understand for which. I assume you are writing for Africa and this thing. So the ones who are answering for Nazca South America, at least write Nazca South America, then write. Because this oceanic, oceanic I'm taking for Africa and South America. Okay, so for Africa, South America, your answers are oceanic, oceanic. Right, everyone has given the answer oceanic, oceanic plate. Very good. And for Nazca and South America plate, what type of we have? Very good, Harsh. Okay, continental, oceanic. Okay, very good, sir. First one is oceanic, oceanic. Second one is oceanic, continental. Even that is okay. Second one, oceanic, continental. Very good. Right, that shows that you people are understanding this. South Africa and this thing, oceanic, oceanic. And now Shipra, you have said along with African coast, oceanic, continental. I don't understand how. इतना समझाने के बाद भी शिप्रा, if you do this, then I would recommend, ठीक है, जाओ क्लास के बाद फिर से वीडियो देखो. This side it is oceanic plate, this side also it is oceanic plate. So then along this margin it becomes oceanic, oceanic only, na? Okay, please watch the video. That's okay. These doubts can happen. Continental, continental for Nazca and South America. Shivam, we have continental on South America, but where is the continental crust on Nazca plate? Is there any continental plate crust shown on the Nazca plate? So this is where you people think that you understand, but many of you have still not understood. So you need to revise. Okay, it might seem simple, but it is not so simple, because if you don't understand this, then later on you will not understand the formations. So that's why I'm focusing so much here. Okay, right? So along Nazca, this is, as I said, this is the Pacific Ocean. This pura map mein dekho. This is South America. This much, only this much is South America. This much. And this is Australia. Between South America and Australia, all the remaining region is Pacific. If you see the atlas. So Nazca plate region also has Pacific crust. This is oceanic crust and this is continental. So Nazca South America is oceanic continental. Okay, oceanic continental. Nazca South America is oceanic continental. Nazca plate is not continental, continental. Many of you have made mistake, I can see. So please revise and try to see in the atlas and then understand. Nazca plate is oceanic crust. So Nazca South America is oceanic continental. Please write this in your copy. Okay, Nazca South America is oceanic continental. नास्का साउथ अफ्रीका, साउथ अफ्रीका नहीं है, साउथ अमेरिका है वो. नास्का एंड साउथ अमेरिका, ओशियानिक प्लस ओशियानिक. रमन अगेन रॉन्ग. Many of you have made the mistake, I can see. So as I said, you might seem to have understood, but you have not. ठीक है, ऐसा लग रहा है कि समझ गए. So you have to watch that part of the video again, okay, and then give the answer. Continental oceanic is right. The ones who have given the answer as continental oceanic are right. The rest are wrong. Everyone else is wrong. Continental वाला भी wrong है, like Jyoti Singh and all, and the others also. The ones who are saying oceanic. Only the ones who are saying oceanic continental are right. ठीक है, so you have to look at what type of crust you have, then you don't have to learn which is oceanic, which is continental. You just have to look in the map, and you can, based on the map and the border and the map, if you understand the map of the world, then you can say, okay. That's why in the beginning of when I was showing you this map, I told you in this the continents are given and then the blocks are given. Those blocks are plates. Okay, so you have to be carefully looking into the atlas or this map. Where is the ocean part? Where is the continent part? Then you can answer. Okay, and you have to see where is the margin. Okay. So now let me ask you another question that might help. Now, if I ask you somewhere, let us say, oceanic, you seem to have understood, so I will not. Now, let me ask you here. Okay. This side. You can see this above part is Eurasian region. This is Eurasian region, Europe and Asia, the continent. And this much, here you have Indo-Australian plate, right? So this Indian part, only this part. If I ask you that along this margin, this one, okay, let me first shade it. Along this margin, this blue colored margin, between Indian plate and Eurasian plate, what type of plates do we get? So along this one, this India map you can see, है ना, इतना तो समझ में आ रहा होगा, इंडिया अपना कंट्री तो दिखाई दे ही रहा है, ठीक है ना. So this is India and this is Eurasia. So along this region, what type of plate do we have? India, Eurasia. What type of plate does it look like? What type of plate combination along India and Eurasia? Can you say? Is it oceanic, continental, or oceanic, continental? Hmm? Very good. The answers which have come, Eurasian and Indian plate, continental. Very good. Right. So Eurasian, Indian is continental. Eurasian and Indian plate, continental. Very good. So hopefully now you understand, right? All the answers I see, Eurasian and Indian plate is continental. All the answers. Okay. Hopefully right. So Eurasian and Indian, Australian plate, continental. Very good. Right. So hopefully you understand this. तो यहाँ आपको समझ में आया, this is continental, right? Good. So let us stop around this place. We understand these. So basically, if we conclude, what is the conclusion? The conclusion is that in this combination we can have, when two plates are there, then depending on what type of crust on the margin we have on the plate 1 and what type of crust on the margin we have on plate 2, we can call them as continental continental, continental oceanic and oceanic oceanic. Hopefully this much is clear. So next class we would start with why it is continental. Please ask the coordinators or watch the video. First I would say watch the video and then, right? So first watch this video, right? I have said, while I have written this, I have said that depending on plate classified on the basis of crust along the margin being considered. Whichever margin you are considering, what type of crust along that margin on the plate you have. So on this basis, now you have to see this video once again. The ones who did not get it, please watch this part of the video once again and try to understand. We have done 3 classifications today. One, major minor. Okay. Second, the NCERT classification, which I said is not a very useful classification. So don't remember that. Remember it only at the time of prelims and go on. The most important classification is the C classification. Okay. Now, what does that say? On the basis of the crust on the margin, we identify the plate, right? What type of crust is on the given margin? For example, in this diagram, along this margin, from this bluish margin, you will call this plate as oceanic plate because you have oceanic crust. Same plate from this reddish margin where you have continental crust, you will call the plate as continental plate. So watch on the basis of this, watch this part of the video, be clear. Next class, we start with the convections. Okay, convections in the asthenosphere and the rising convection, sinking convection, etc. Hence divergence, convergence, transform movement, all that. And then we'll go into one by one the other possibilities. Okay. So plate tectonics we'll continue in the next class. Read what is given in your NCERT. Read what is given with Vision IS handouts. Okay. If you want for plate tectonic, you can refer to Vision IS handout. Okay. And then next class we'll continue from there. So hopefully this is clear. Focus more on the class, right? Please revise the previous things when you come to the class. That will help you in the next class. Okay, and chapter is chapter number 4 of NCERT and Vision IS handout of plate tectonics. I would expect you to read this and come. GC Leong plate tectonics is not given, so I would not recommend you to read GC Leong. Okay. Right. So that's it. This is where we end the class. And coordinators, I know you would get a lot of doubts today. Okay. The class has been slightly turbulent today. Right. But if you focus on what we have done in the class, right, without getting into different chats, I think you will get it. Okay, things will be understood and then we can go beyond. Okay, so that's it. Let us stop here and let us start in the next class with the remaining part with revision from your end. Okay, don't worry. Don't worry, I'll make you understand. In the next class also, we'll start slightly with a bit of revision and then we'll continue. Okay, that's it. Let us stop here. Thank you. Coordinators, thank you. The class is over. टेक्निकल टीम अभी माइक ऑफ करते हैं 2 मिनट में. Is there any doubt you want me to take up? The coordinators? Any doubt you want me to take up? Right. So I will consider this to be over. Thank you, Sangeeta ma'am. Technical team, Michael.